Alright, so in this video we're going to start with another kind of unusual example where it's not a straightforward u substitution, and then after that we're going to start looking at definite integrals. So let's get started with this example here, where we want to evaluate the antiderivative of 3 divided by 1 plus 25 x squared dx. Okay, now there's a couple of ways that we could start this problem. One of the ways that I would start it, if I were you guys and trying to get a handle on this, is I would be like, okay, well let's let u equal 1 plus 25x squared. Okay, now the issue with that is that when I take the derivative of both sides, I'm going to end up with 50x dx. Now, while that wouldn't be a huge deal usually, the issue is that I don't see an x or a 50 anywhere. And it wouldn't make sense for me to divide both sides by 50x, because then I'd have an x that's still muddled together with the du. So I just feel like this wouldn't lead me anywhere. So I'm going to go ahead and try something else. I'm going to look at this, and what I'm going to do to kind of get myself started is I'm going to take this 3, I don't know why it's bugging me, I'm going to move it out to the front. So let's take this 3, move it out to the front, and we will rewrite this as 3 times the antiderivative of 1 over 1 plus. And now here I have 25 and I have x squared. The thing that's interesting about this to me is that 25 is a perfect square, and x squared, well, that's also a perfect square. So how can I write this as 5x, that whole thing squared, dx. Now, the reason I did that is because this actually looks like something that we know the antiderivative of, and what it looks like to us is that it kind of looks like 1 over 1 plus, I don't know, let's call it u squared for fun. Now, if I actually got it to look like this, well, the antiderivative of this guy is tan inverse of u, okay, plus c. Well, that's really cool. So all I have to do now is let my u equal this. So let's go ahead and do that, move forward and see where we can get. So why don't we let u equal 5x, which means that du is going to equal 5 dx. And I don't have a 5 attached to this dx, so I can just divide both sides by 5 or multiply both sides by a fifth, whatever you want to do. So I get 1/5 du equals dx. Now, when I substitute that all in here, what I'm going to get is I'm going to get 3 times the antiderivative of 1 divided by 1 plus u squared. And remember, dx is equal to 1/5 du, so that's going to be 1/5 du. And remember, 1/5, that's just a constant, so I can move that out in front. So it's going to be 3/5 times the antiderivative of 1 over 1 plus u squared du, which is going to be 3/5 times tan inverse of u plus c. Awesome. Now don't forget, we wanted it not in terms of u, but in terms of x. So we're going to rewrite this. That's going to be 3/5 tan inverse. And instead of u, what did we let u? Oh, u is equal to 5x. So it's going to be 5x plus c. That would be our answer. Great. So there's just another kind of unusual case of where we would use u substitution. So that is the last one that I wanted to talk about. The next thing that we are going to do is we are going to look at evaluating using u substitution when we actually have balance. So let's look at this example where we're looking at the integral from 1 to 3 of x squared plus 1 to the third x dx. Alright, so we're going to be using use substitution on this. So I'm going to look for my inside. That's usually the first thing you want to do. So I have an inside here. This is inside those parentheses and raised to third. So we're going to let u equal x squared plus 1. And then du is going to equal, well, that's going to be 2x dx. And notice that I just have an x dx, I don't have a 2x dx, so just multiply both sides by 1/2. So 1/2 du equals x. Now, I could move forward and plug this in, but notice that I've done substitution for every part except for what part? Well, I haven't done substitution on my bounds, right? Because if I change these variables, well, my bounds are going to change too. So, to change these bounds, it's not that bad because I'm saying, well, x goes between 1 and 3. I just have to figure out what my u goes between now. Well, since u equals x squared plus 1, then my new, that's supposed to be a u for upper bound. My new upper bound is going to be 3 squared plus 1. So my new upper bound will be 10. And my new lower bound, or however you want to write this, is going to be, so that's 1, so it's going to be 1 squared plus 1, which equals 2. So not only am I going to plug in a new variable for my x and my dx, I'm also going to have new bounds for my integral. So let's go ahead and evaluate that and see what we get. So now this becomes the integral. Remember, we changed our upper and lower bounds, so instead of x going between 1 and 3, now we have u goes between 2 and 10. That's going to be 2, this will be 10, 10, 10. Alright, so here, x squared plus 1, well, that's going to be u now, so it'll be u to the third. This x dx, that's going to be 1/2 du. Go ahead and take that 1/2 and shove it out to the front. And take the antiderivative of u to the third, so that's going to be u to the fourth, divided by 4, and we need to evaluate that from 2 to 10. So let's see, that's going to be 10 to the fourth, divided by 8, minus 2 to the fourth, divided by 8, to give us 12/48.